Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Perspective by Matt Tressel, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have yin-yang shading, where we need to divide the grid into two distinct regions such that each region is orthogonally connected and no 2x2 area may be entirely in one region. So this is an example of a valid yin-yang shading, because you have two regions, each of which is orthogonally connected. And what does it mean to be orthogonally connected? It means you can go from any cell in a region to any other cell in that same region just by going through edges, all while staying within the region. So for example, you can go from this cell to this cell here by going through these edges while staying within the region. And similarly, this is an orthogonally connected region because you can go from this cell to this cell just by going through these edges, all while staying within the region. Now, an example of an invalid yin-yang shading would be something like this, because now these cells cannot get to the rest of the cells in their region just by going through edges. They would have to go through a corner or go through edges and exit the region, which is not allowed. This is also not a valid yin-yang shading because this 2x2 area is entirely unshaded, which is not allowed. And similarly, this can't work because this 2x2 area and this 2x2 area is entirely shaded, which is also not allowed. So that's an example of how yin-yang shading could work. We have non-consecutive yin-yang, where orthogonally adjacent cells within the same yin-yang region may not be consecutive. So for example, if this were, say, a 6, we know these cells could not be 5 or 7. Actually, let's do this one. Let's say we have a 6 here. We know that these two cells could not be 5 or 7 because within the same yin-yang region, orthogonally adjacent cells, which means cells which share an edge, cannot be consecutive. So therefore, these cells can't be consecutive and these cells can't be consecutive, which means 5 and 7 could not be here or here. However, these could be 5 or 7 because they are not in the same region. And that's how non-consecutive yin-yang works. And we have entropic yin-yang pairs, where a cell with a pair of arrows containing the digit n will target two cells that are n cells away from that cell in the direction of the arrows. So this cell, say we had a 6 there, it would target these two cells here. The two target cells must be in different yin-yang regions, which they are, and each digit from the target cell and the clued cell, n, must be from a different entropy, either from 1, 2, 3, which is low digits, 4, 5, 6, which are medium digits, or 7, 8, 9, which are high digits. So this could work very well if, say, we had a 3 or 2 here, and let's make this a 7. So 6 cells away in both directions must be, first of all, these two must be different yin-yang shadings. And then for these 3 cells, we have to have one from each entropy set. One being low, one being medium, and one being high. And the 6 is from the medium, the 2 is from the low, and the 7 would be from the high. So that's how these entropic yin-yang pairs work. Fascinating. And obviously, you cannot point to digits that are outside of the grid, right? Um, Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we have to start with the paros because we have no information about yin-yang shading. So how far can the paros go is kind of a question. So this can go up to 6 cells this way. So and 6 cells this way. So this is at most 6. We have 1 through 6 here. Let's make just the highest digit right now. So this is 6. This is also 6. This is 5 going that way, so that's 5 at most. This is 6 going that way and that way, so that's 6. This has to be 2 or 1. So this is 1 or 2. So that's helpful. This can go 1, 2, 3, 4. So this is 4 at most. This can be up to 5. Either way. This can be up to 5. This is also 4 at most. This is 3 at most. So this is 1, 2, or 3. This is up to 4 at most. Away. We have here 1, 2, 3, 4, 5, 6. This could be 8, but this is 6 guaranteed at most here. So that's 6 at most. This is also 1 and 2. This sees 1, 2, 3, 4. So this is 4 at most. This is 1 or 2. Because it can only go 2 here. So this has to be 1 or 2. This sees 1, 2, 3, 4, 5, 6 at most. And this could be 7 this way or 8 this way. So this is 7 at most. Well, in row... So 1, 2, 1, 2, and 3 are all low digits. So we can color those as blue. We have a 1, 2 pair in row 7 and in column 7. So the rest of the row and column cannot be 1 or 2. So this has to be 3, 4. This is 3, 4. This is 3 through 6. This is 3 through 6. And this is 3 through 6. Okay. We don't have any extra information here, though. So this has to be 1 or 2. Which means we have a medium and high pair in this direction somewhere. So either this is 2, which would force that to be medium, or this is 2, which would force that to be medium. This cannot be 6 away. 6 away would be 1, 2, 3, 4, 5, 6 there, and 1, 2, 3, 4, 5, 6 there. And the problem is, obviously, this would be a low, 6 would be here, and then this is 6 at most here, so it cannot be 7, 8, or 9. So this cannot be 6 here. Can this be 6? I think the answer is no, too, because this is essentially symmetrical. So 1, 2, 3, 4, 5, 6 has a problem in that this is 1, 2, 3, 4, 5, 6 is a low. This would have to be less than 6, so cannot be high, and this can't be high. So 6 doesn't work here, and I don't think it also works here, right? If this is trying to be 6, well, actually that could work. This could be 6. This would have to be 3 then, in that instance. So if we have 6 here, this would be 3. So we have a 3, 4, 5 triplet, actually, in also row 7, which means the rest of the digits in the row are 6 through 9. Um, hmm. Remaining digits, again, in column 7 have to be 3 through 9. Okay. Seven away, 6. So it's 3 or 4. Okay, so one issue, though, is if you have this being 6, this would obviously have to be 3, and this would have to be a high digit. And they would have to be different shadings. I mean, that's possible. But obviously this couldn't work then either. Well, obviously it wouldn't be 6 then. Okay. Okay, so we have all of these. So let's just put in the digits that are possible for these. So this is 1 through 7. We have 1 through 5 in both of these. This is already 3 or 4. This has to be 1 through 4. And these have to be 1 through 6 here. This is 1 through 4 here, and this is 1 through 5 here. Okay. Can we eliminate some possibilities? This can never be 2. If this is 2, these two would be the target cells, but we need a high digit from one of them, and they can't be high. So this cannot be 2. 3 could work. 4 technically could work also. This cannot be 4 because we need a high digit from one of these two, and neither of them could be high. This can't be 4 because we need, well, this would be a 1-2 pair, and they would both be low. Okay. Can this be 2? No. If this is 2, then this would be, these would not have a high in loud. 3 away could work. 1 away could work. 2 away could work. So these are the only informations we have, really. Can 3 away work? Possibly. This cannot be 2 either, because again, we need a high digit in both of those then. 4 away. Does 4 away work? No. If we had 4 away here and 4 away here, these two digits could not have a high digit. So it's 1 away, or it's 3 away here. Interesting. So this is 1 or 3, which is a guaranteed low. Okay. 3, 4, and 5. Let's mark all of these, I guess. Are all low or medium. Okay. 6, 7, 8, 9 are all high and medium. So 3, 4 works. Hmm. 2 cannot work anymore. If this is 2, that guarantees this is low and that's low, and that doesn't work. So this can't be 2. 4 away could work if this is 3. Does 4 cannot work here, and 4 can't work here. Because if this is 4 away, this would have to be low and low then. That would be 3 and 1. And we don't have a high. So this cannot be 4, and this can't be 4. We have a 3, 5 pair now in row 7, which eliminates 3 and 4, 3 and 5 in the rest of the row. This can't be 3, it's 4, which means this is not blue, this is red. 4 away needs a low here or here and a high here. So this has to have one low and one high. We are guaranteed already 3 lows in row 3 then, which means the rest of the row cannot be low. This can't be low, it's medium, which means this is 5 or 6 away. The rest of row 3 then have to be medium or high. Okay. 5 away. And these are different shadings too. I don't know how I'm gonna do shading along with this, but well, we know this swaps between here and here. So it swaps once in one of these areas, and it swaps once in one of these areas. Okay. One of these is 3, and one of these is 5. Well, the 5, if it goes this way, 1, 2, 3, 4, 5 would force this to be a high digit, and therefore this would have to be a low digit. Same with this. If this is 5, this would be a high digit here, so that would have to be a low digit there. So one of these two is guaranteed to be a low. We don't know which. Okay. Hmm. Hmm. Um, must be different clues or different region, yin-yang regions. Um, hmm. 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 Okay. One of these is going to have to be 2. So, okay, we know this changes yin-yang regions here. So these are different regions. One of these is guaranteed to be 2. So that means either this is going to have to swap regions here, or this must swap regions here. Well, so we have one swap here. We have another swap here. Sorry, we have either a swap here or a swap here. It can't in yin yang shading. You cannot swap. You have to swap 0 times on the edge of the grid, or 2 times. You can't swap an odd number because obviously you only have 2 shadings. If you try to swap once, it's going to have to swap back to the other color, right? So that's going to be at least guaranteed 2. But that means you can't. If you try to have 4, you can't have 4 because if you try to swap from 4 times. So you have one swap here. So you have one shading here. You have the other, let's do yellow and pink. Maybe yellow and orange. Yellow here, orange here. Yellow here, orange here. How do you orthogonally connect the oranges together without breaking apart the yellows? You can't. How do you orthogonally connect the yellows together without breaking apart the orange into 2 regions? You can't. So that's why you have to have either 0 changes of color or changes of region in the edge or 2. We know these are separate regions. So that's already one change of color here. And that means this is going to be one change, and this is going to be one, or this is going to be one change. Either way, the rest cannot change in these cells. So we cannot, this is going to be the same coloring in this region. This is going to be the same coloring in this region. This is going to be the same coloring in this region. So we cannot have a change in colors in these cells here, or these cells, or these cells. Because we know we have a change of region in here or here. We have a change of region in one of somewhere here. So therefore, that's 2 changes of color guaranteed on the edge. Therefore, these cannot change color at all. You could have 4, and that could work. Well, no, this could be 2. 3. Okay. If it's 2, it has to be with 5, right? So 2 away has to be 5 and a high digit. 2 away would have to be 5 and a high digit there. If this were 6 and 6, these are different regions. These are different regions. So we know these would have to be the same region here. So since this is the same region, you'd have a swap here. You could not have a swap here because it would be swapping once to the different region and then back to the same region. So this would all be the same region, which means this would have to be 1. So same, this was 6. If we have 6, these are different regions, definitely. These are different regions, so these must be the same region here, which means this cannot be 2 to swap regions here. This has to be 2 here. So that's 2. This is 5 in that case. So 5 away would force this not to be medium. This would have to be high. This would have to be low. These would be different regions, so we swap there. So this would have to all be the same region. So this would all be the same region. You'd have to swap somewhere here. This would be orange, this would be yellow. So that works okay so far. This would be 1, this would be 3. Obviously, this would have to be orange because of the 2x2 area. This would have to be 1. So this would have to be high. Or actually low and high, we don't, or medium and high, we don't know. These are different regions, though. So one of these would be yellow, one of these would be orange. We're not sure which. So far that looks fine. This would be 3. So 3 away would have to be high, and this would be low. Oh, that's interesting. I didn't realize that. Huh. If this is 5, this becomes 3. They're both pointing to the same digit here, which obviously has to be a high digit. And then the high digit, well, I guess that would be medium then, right? Because this would be 3 as a low. You'd have to have a high digit that it's pointing to because the 5 is pointing to that digit also. So that would be high. Therefore, we are guaranteed a medium in one of these two cells, but we don't know which. So that doesn't really help us too much, but it's something interesting to take into account. So that's looking like it's fine. We do know this is green, or one of these is green. Okay. Hmm. What happens if this is 1? So if we have 1 here, these are different regions. This would have to be medium. This would have to be high. So therefore, this can never be low. So we cannot have 5 there. So then this would be 3, this would be 5, this would be 2. So that actually does work. Because 2 has to be with 5, right? So... We do know one of these is green. So if this is 1, the other one would have to be red, but we don't have a guarantee that's 1, right? So let's again, okay, let's try this as 1. If this is 1, that's 2, that's 1, that's 2, right? So these have to be different regions. These have to be different regions. So we know pink would have to be essentially going here. And this would be all one region here. So this would be yellow, yellow, yellow. This would be pink, obviously. This would be yellow. This 2 means this can't be 2. That's 5. This is 3. 5 away cannot be medium, so this would be high. This would be low. 3 away would be medium. This would be 1 away, so this would not be... So if this is 1, this is medium, because this is low. So we have low here, this is medium here. This has to be high, which means 5 away has to be low here. 3 away has to be medium, because this is low. 1 is, that makes this medium, this is high. So that's fine. These are different regions, these are different regions. These are different regions. This can't be 3, though. No 1 or 3 here. So far, that's fine. These are different regions. That doesn't really tell us much, though. We know this cannot be 6 because these are the same region then. So this would have to be 3, 4, 5. 1, 2, 3, 4 does work in this instance. Because these are different regions. Huh. This can't be... This could be 1 or 3. We don't know. Hmm. 6 does not work here because these would not be different regions. So this would then be 5. No 5 here. This is not green, so therefore this has to be red here. 5 away would have to be then low. Okay. 4 could work here because these are different regions. 3 could not. 1, 2, 3. 1. It could be 3 still here. These are different regions. No 3 here because of 3 in the column. So far, this is looking fine. The problem is I need... Yeah, okay, so this can't be 2 here. So this has to be medium. Oh, sorry, it can't be low. So this has to be medium. This can't be low. It has to be high. Which means this can't be high. It's low there. So this is not 3. It's 4 or 5. 1, 2, 3, 4. Okay, well, that's one thing I didn't rule out. So this can't be 4 for the same reason this can't be 4, right? It's pointing to both of these, and neither of these could be high. Okay, that looked like it actually worked decently well. So let's try it this way. What happens if this is 2? Then this becomes 5. This is a high digit. No low. This is not 5. It's 3. So this would be 1. We don't know what this is. This would be 3. This 5 away cannot be medium. So therefore, this would be low, no low here. 2 would make this not 2. That's 1. That's 3. 3 away would mean a medium and a high. This can't be that. So this would be 1 away. We'd swap here. So this would have to be orange. This would all have to be yellow. And it was all yellow. Look at the stars. Oh, that's one interesting aspect. So, even without the 2, if this is 5, obviously this can't be 5 then. If this is 3, this has to be 5 here, which makes that a 2 to be corresponding. So we're changing here. Therefore, this can't change here because we have already one change here and one change here on this edge. So then you can never have 5 here because that would be 1, 2, 3, 4, 5, and 5 away, and they would have to be different regions. So this can never be 5 then, right? Either you have a 5 here, which means that can't be 5, or this is 3, which makes that 5, and that has to be 2 with it to correspond because 2 has to be with the 5 to make that work as a low, medium, high triplet. So then, because this is 5, this is 3 and 1, 2 has to change here, which means this can never change in this area because it changes once here too. So therefore, this can't change. Therefore, this can never be 5 because then these would be different regions, even though there's no change allowed. So this cannot be 5 here. This cannot be 5 here. Interesting. But one of them could be a 4. We don't know. That was interesting logic. Let's try the same thing. So if this is 2 and that's 5, this is 1 and 3. That means this is 1, that's 3. 5 away has to be different entropies, so this can't be medium. Obviously, it's not medium here, no low here. This is swapping here, so this is high. So we have to have yellow here, orange here. That means this is all yellow. Or I guess it could be all pink too, but I don't know. That means this is orange. We have orange going to here. It swaps somewhere here. This is 1 away. 5 away is low and high. 3 away is high and a medium. Okay, 3 away here has to be a medium-high pair. Okay. So far, that's looking fine, too. Obviously, this can't be 3. This can't be 3. So far, that doesn't tell us much. These have to be different regions. That doesn't tell us much. These 2 have to be different regions. That doesn't tell us much. These are different regions. That also doesn't tell us much. These are different regions. That doesn't tell us much. This cannot be 3 anymore. Interesting. Okay, so in this scenario, if this were 3, so we tried 1 and 2 here. So we tried 2 here. If this is 2, this can't be low, so this has to be 5 or 6. If we have this trying to be 3, this is definitely medium, and this can only be low or medium. So that doesn't work, so this is medium. So no matter what, this has to be medium here. Interesting. Good to know. So that's helpful. So we tried that both with that being 2. Obviously, that has to be medium. And this being 1. And that led to this scenario where this can't be 3 that way. But this could be 1. The key is that this can't be 1 here. Guaranteed. So that's why this always has to be then medium. Interesting. So it's 5 or 6 away. Or 6. Huh. Oh, but okay. So what happens then? So can this ever be 6 here? If we have 6 here, that means 1, 2, 3, 4, 5, 6 away cannot be medium. It has to be low. So that's 3. This is 5. But then this would have to be 2. That would be 1. This would be 3, 2, 1 here. These would have to be different regions. So pink would not be here. This would all be yellow. This would have to be a high digit with the 3 and 6. So this would be different regions, yellow and orange. The 1 and 1 would be different regions. These would be different regions, so this has to be orange. So we have orange all the way around here. This is yellow. This is orange. Obviously this can't be 6. We know this is not, so this is not blue here. That's orange, or this is green. No green here, it's blue. Green means this can't be green, that's red, which means that's blue. This is red and blue, so this must be green here. This is 6 away. It couldn't be 3. That's the reason why this can't be 3. Otherwise it's 5 there. So if it's 6, this is low and 3. So no 3 here, no 1 here, no 1 here. Okay, this is all orange. This is high. Okay. So far this is working fine. This has to be high. One of these is yellow, one of them is orange. We don't know which. 3 away has to be high or medium. This is 3, 4 as a pair, which eliminates 3, 4 in the rest of the row. This cannot be 3. So that's 1 or 2. This is 1 or 2. That means we have a 1, 2, 1, 2 pair in column 4, which means this can't be 1, 2. It can't be 3 because of 3 in the box. So this is not low. This is also medium. And it's 4 or 5. 1, 2, 3, 4, 5. 4 could work, as that would be high. 5 would force that to be blue and 3. Well, that's not true. It could be low here. Never mind. So 4 or 5 could work in that instance. 4 away here does not work because that would be 6. So then this would have to be 3. This would then be 4. So this would be low, not green. And these would have to be high or medium, high and medium. 4 here does work. So then that would be not medium because this is not low. So then this would have to be not medium. So that would be 3 away. And this would have to be high. And they are different regions. So that's fine so far. And then we'd have 3 and 3, which is a contradiction. So this cannot be 6. It has to be 5. Interesting. Not sure I like that, but okay. So this has to be a 5. We know that for certain, which eliminates 5 in the rest of the column. That means these have to be different regions, but these are a low-high pair. 5 eliminates 5 from the rest of the row also, aside from moving it from the column. That was a long, convoluted way of showing that, but okay. Oh! How did we know that this had to be, if this was 6, this had to be 1? I guess we should try that then also, just to make sure. So what happens if this is 6 and 2? Then this becomes 1 and 3. We have 2 and 5 there. This swaps here. Oh, and then this 6 becomes 5 there. That's the reason why. So that doesn't work. That's why this is 5. No 5 here, no 5 here, no 5 here, no 5 here. So we know this is a low-high pair here. This is a low-high pair, obviously. Now the question is, can this be... We were trying that with 1 being there. What happens if we try with 1 being here? 1, that's 2 and 5. This is 1 and 3. So not low, not medium, not low here. 5 away means this is not medium, that's high. This is blue there. This is green. 1 eliminates 1 here. So that's 3. 3 away then. This is blue, which means this can't be blue. This is red, which makes this not red, that's blue. Therefore, this must be medium here. We swap here. So then we have orange here. And this is not, this is yellow. So we have yellow here. This is orange here. This is high. So far that works fine. 3 away. This 1 eliminates 1 here. No 1 here. I don't think this can be 3, right? Or this can't be 4. If this is 4, this becomes 3, and then this has to be 3. So then this would have to be 3, that would be 4. Which means this can't be 3 here. So this is low. But it's pointing at a low. So that's why this can't be 1. There we go. Long, convoluted way of showing that. I don't know. There maybe have been a better way to find that out. But this then has to be... We don't know if this is 1 or 3, but this is 2. This is 1. This is 2. That makes this 5. So 5 away, this is low. Sorry, this is medium. This is not medium, that's low. So that's 3. This is different sets. So we have pink here, going to pink here, and orange is the same as yellow. So these are all yellow. This is yellow. 3 eliminates 3 here. 5 away cannot be medium, so that's high. 5 away has to be low then, which means this can't be... Well, we know this is low. We don't know what this is. This is 3 away from here, so this is medium. Okay, 5 away is blue and red. 6 away does not work anymore here because these are the same region. So this must be 5 away. And this cannot be medium, therefore this is high. This can't be medium or high, it has to be low. Okay. This can't be 5, so 5 has to be one of those two because this is low. This can't be 1 or 3. Okay. 5 ways, blue and red, they have to be different regions. 5 ways, blue and red, those have to be different regions. This is pink. One of these is pink, one of these is yellow, so this is a pink-yellow pair. This can't be 6, obviously. It's 7, 8, or 9. If this is 4, we have the same problems, though. That means this is low and this is low, because this has to be 4. It points to that and that. Actually, it can't even be that, because that points to... it points to this and this. But the thing is, since it points to that, this has to be low. This is 4. This has to be low, because it's now 1 and 3 only, but we have 4 lows guaranteed in column 3 then. So this cannot be 4, this is 3, which eliminates 3 in the rest of the row. So this is not medium, this is low. Therefore, there's no more lows in the column. So 3 away has to be a medium-high pair. Okay. And they're different regions. Rest of column 7 are medium and high. One away could work, 3 away could work. 1 or 2. Six, 3 away. 3 away would mean that's medium and that's high. That could work. 1 away would make that medium and that high. That could work. Three away could work here. Medium, high. One away could work. 2 away could work. 4 away seems like it could work. Blah. Hmm. Huh. 5 has to be, cannot be here, so 5 has to be one of these two. Hmm. Yeah. Hmm. So this is 1, 2, or 3. We have 4, 5, 6 here. We have 1 or 3 there. These are different sets. We don't know which. If this is 1, this is green and that's red. If this is 3, this has to be red and that's green. But that doesn't really tell us very much right now. Huh. Oh, right. No orthogonally adjacent cells within the same yin-yang may not be consecutive. There's also that. Interesting. So this cannot be 2 here or 4. Um so remaining digits in box 9 are 2, 4, 5, 6, 7, 8, and 9. No 2 or 4 here because these are guaranteed to be the same set. Or same region. This is 1 or 3 here. So these have to be different regions here. Oops. Edge only. Hmm. So 2 has to be one of these 3. 5 is one of these 4. No 2 or 4 here. Hmm. Okay. Oh, interesting. We are guaranteed in row 3, 1 out of 4 of 6 is going to be at least one of these digits. Does that help us much? I don't really know. Maybe, maybe not. Who knows? Um, hmm. We know 4 or 6 cannot be here because they are the same region. So this is blue or red. We don't know anything about this, though. Hmm. Mm-hmm. So this has to be 1, 7, 8, or 9. And this is 1, 3, 7, 8, or 9. So that's not too helpful there. Uh, hmm. So one out of these must be 4 or 6 for the mediums digit. Hmm. 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 Okay. Hmm. Uh. Oh, this swaps here too. This is 2. So this is all pink. That makes this yellow. Okay, that's pretty useful. So this has to be blue or red also, because it cannot be green. Um, hmm. We have yellow here. One away would be pink, so this would be yellow. Um, If this were 2, this would have to be 6. Huh. So these are different regions. This cannot be low, it's high. So this is 7, 8, or 9 because of the 2 here. So then this has to be low here. Because this 4 must be pointing to a low. So this is 1 or 3. So this 1 or 3 is in the same region as this. So this cannot be 2 here. So this is 1, 3, or 4 here because they can't be consecutive. This is low. This can't be 2 for the same reasoning. Hmm. 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 Huh. These are different regions. So this is pink, therefore this must be yellow. These are different regions, but we don't have the region for it. This, I guess this could be yellow here, and that could be pink. This is pink, which makes that yellow. Okay, so that's done. This is pink and yellow. That's done. We don't know what these colors are. We don't know what regions these are. We don't know what regions these are. This is 3. So these are different regions, and these are different regions, so these must be the same region. So we know those are both orange. Doesn't help us too much, but 4, we have different regions. 1 different regions. 3 different regions. 5 different regions, but we don't have anything else. These are different regions, so that's done. Ugh. This is kind of tough. Okay, this is 7, 8, and 9 also. 4, 6, 7, 8, 9, 4, 6, 7, 8, 9, 4, 6, 7, 8, 9. Okay. This digit cannot be 2, 3, or 4. So we have 1, 5, 6, 7, 8, and 9. If this were 2, this would be yellow, so this would have to be red or pink, which would make this yellow. That could work, which would make that pink. Wow, this is pretty convoluted. So this could be non-2 or 4 if this is a 2, 4. Well, one of these would be 2. We don't have a guarantee about 4, though. 7. Can it be 6 away? Yeah, possibly. Oh, this is a high digit. So that's 7, 8, 9. 5 has low and high with it. 5 has high and low with it. 5 has high and low with it. 3 has medium and high with it. 3 has high and medium with it. 2 has medium and high with it. 6 could work here if this is high. And then this would be pink. So that does work. Otherwise, it's 1 or 3, which would force this to be 4. Oh, this can't be 4, because a 4 would point to a 5, and they would both be medium. So this is 1, which makes that 2. That makes this 3. This can't be 1 or 3, it's 6. Okay, that helps a lot. That helps quite a bit. Okay, that's very useful. No medium here. This is not low, so this is medium, so the rest of the column is medium or high. 1 away. These have to be separated because they have to be different regions because they are adjacent to each other and not well, yeah, 1. So these have to be medium and high to be with the 1. And we have 6 digits in column 4, which have to be medium and high. Therefore, these cannot be medium or high. This is to be low. No 2 or 4. This is 1 or 3. We have a 1, 3, 1, 3 pair in low. This cannot be low. This has to be high. So this has to be 2 here. The rest of this, so this has to be low here, and it's 1 or 3. The rest of this box cannot be low. It has to be medium or high. 6 away means these are different digit. This is high, and this must be pink because it cannot be the same as yellow. So therefore, these are pink. This has to be high now. Why is that? It had to be high or low. Is there what was pointing to it is the question. Why did that have to be high or low? Why couldn't it? Oh, because it would be consecutive with this. Right. Right. Okay. So that's fine. Then this is 7, 8, or 9. We know these are pairs. So this is pair of green high, green red, pair of green red. So this must be pair of green red. But that doesn't really tell us too much. Pink, pink. This is high, so this is 7, 8, and 9. We have 7, 8, and 9 here. This is a blue-red pair for the 5. We have a 7, 8, 9 triplet in box 3, which eliminates 7, 8, 9 in the rest of the box. So this is 4 or 6, which means this is medium, and therefore there must be a border here because they're consecutive, guaranteed. So this is yellow. So we know this is yellow. Is anything pointing to that? I don't think so, right? These are different regions. 2 away is here. So this must be a green-red pair. Okay, that doesn't help us too much. This 1 eliminates 1 from being here, so that's 3 or 4. If this were 3, this would guarantee that's a 4, but then they would be consecutive in the same region. So this cannot be 3. Therefore, this is 1, that's 3. Interesting. 3 away cannot be blue, so this can't be blue, that's red. That means this can't be red because of the 5 here, so this is blue. Cannot be 1, it's 2 or 3, this is 7, 8, and 9. This is yellow, because this is pink. 1 is here, 3 is here, this is high, this must be low here. And this is yellow, so this must be pink here. Interesting. Okay. So this is yellow. Remaining digits in the box 3 have to be blue and green. Remaining digits in row 5 are green and red. Okay. So green and red, green and red, green and red. Red and blue. Not blue, this is green here. Oops. Okay. So we have red or green here. Red or green here. Red or green here. Green and red. That's 5. Where is 2 in row 6? Can't be here because of 2 in the box. Can't be here. Can't be here because this blue eliminates that possibility. This can't be consecutive with 3 because this is the same region. So 2 has to be here, which means this is not red. That's blue. Is there anything pointing to that? Because why do we know this is... Oh, because it can't be green next to the 5 because it's the same region. That's why. Okay, so this is 2. Where is 2 then? 2 has to be one of these 2 digits here in row 4. Two. Where's 3 in this region? It has to be one of these 2 digits. Where is 3 in box 5 then? Can't be here because of 3 in the column. These can't be 3 because there's no low digit here for the entropic paros, for the 1. And can't be here because this must be medium. This has to be medium or high. So this must be 3 here and is low. Where is 1 then in column 6? Oh, this is 3, which makes this 1. Oh, interesting. So this is 1, which means this must be... This is pink, this has to be yellow. 1 in... That makes this 3. So we have 3 here. 1 has to be one of these 2 digits here. These are the same region, which is different from this region here. I guess we can make it dark or something. I don't know. 3 away could work, as that would be 5 and this would be high. Four away could also work so far. This cannot be 3 or 4 because they are the same region and therefore they would be consecutive. Has to be 6 through 9 there. What about these digits? Okay, 2 can't be here, 2 can't be here, 2 can't be here in box 1, so 2 has to be here. So this is 2. Remaining digits in column 1, where's 3? Well, 3 can't be here. 3 could be here. Okay, remaining digits in column 1. We have 3, 4, 6, 7, 8, 9. Obviously, 3 cannot be any of these. So this cannot be low. So this is medium or high here. This can't be 3 because it's consecutive with 2 and they're in the same region. No 6 is here because of 6 in the box. This can't be 6 because of 6 in the box. Where is 6 in row 3? It must be one of these two digits here. Interesting. We have 1 here. This is 2. Remaining digits of row 1 are 3, 4, 7, 8, 9. Obviously no 3 here because of 3 in the box. Where is the 3 then? It can only be here. So this is 3 here, and it's not green, so that's blue. We have 1 remaining in this box, and it has to be one of these two. Okay, 2 is one of these two. One of these is a 4. We don't know which. This... Wait, how did I make that? This is 3 or 4. I don't know how I got that. Okay, anyways. One cannot be any of these, so 1 has to be one of these two. Where is 1 in box 5? It must be one of these two. Box 6 has to be one of these 4, but that's pretty broad. This is yellow, pink. 6 is pink and yellow. 1 is, this is pink, so that's yellow. 5 is, that's pink, so that's yellow. Paro, this is pink, so that's yellow. 3, this is yellow, so that's pink. 5, we don't have information on. 3, we know this is yellow, so this must be pink. Okay. 1, we don't have any information. 2, we don't have any information. 3, we already did that. 1, we don't have any information. 3, we just know that these are different. 5, we know that those are different. This is pink, so that's yellow for this paro. And this is pink, so this is yellow for that paro. So we've got all the colorings for the paros that we have. This is high or 5, or high or medium. Cannot be 2 or 4. This has to be, oh, this is a 1, 4, 6 triplet here, which eliminates 1, 4, 6 in the rest of the row. So this cannot be green, because it can't be 5, it can't be 6, it can't be 4. So this is high and 5. Sorry, high and red. This can't be 4 here. Remaining, so this is low. So these are low or high. And... Right. So we're guaranteed so remaining digits in row 2 are 3, 5, 7, 8, 9. But 3 can't be either of these. This can't be 3 or 5, so this is 7, 8, and 9. We are guaranteed a 4 in column 3 has to be one of these two digits. So therefore this can't be 4, that's 3. So 3 away is guaranteed to be medium. This is not medium here. This is low. That means low cannot appear in the rest of the column. So this can't be 3. It's 7, 8, or 9. Where is 3 then in row 2? Can't be here, can't be here, can't be here or here. So it must be here. So that's 3, which means this is not red. It's blue. And it's yellow, so therefore that they can be next to each other. This can no longer be 3 here. 4 has to be one of these two. That's the whole reason why we knew this was 3 here. 4, 7, 8, 9. Um, 3 away. That means this is pink and this is a different region, so that's yellow. This is medium, so this can't be medium here. This is high, so this is 7, 8, and 9. If this is pink, this had to be yellow anyways. So, and if it's yellow, it doesn't have to exit out that way, so that's fine. This is medium or high. So 3 has medium and high, and they are different regions. So yellow and pink. Hmm. So we have all the ones kind of set out. 2s. 2 here, 2 in one of those 3, 2 in one of these 2. 2 cannot be here. They are the same region. So where's 2? 2 has to be here. Which means this can't be 2 here, so one of these is 2. This is low, obviously. So this cannot be low. It has to be medium or high there. This can't be 1, 2, 3, 4, so 5 through 9 there. 2 is one of these two. Okay. It's pretty convoluted. Threes. Let's see where threes are. We have 1, 2, 3, 4, 5, 6. We have all the threes. Okay. Interesting. So if this is 4, that does work. So that would be 2, and this would be high. 1 also works here, too. 2 also works here. So we don't have that much information. This is not helpful, so right now we'll clear it. We can probably get rid of the blues because we have a lot of that information already set. Hmm. Hmm. Yeah, let's remove the blues. Actually, that doesn't help us much. Um, hmm. This is pink. This is yellow. This is yellow. These are all pink. Okay, let's just make sure the paros that we have are correct. 6 away is 3 and a high digit, and they are different regions. This is yellow, that's pink. 1 away, this is pink, that's yellow, and interesting. So one of these is medium, one of these is high. We don't know which is which. 5 away, we have pink and yellow. This is 2, 5, and a high digit. So that's fine. Paro here, that's 3 away. This is we don't know. This is high digit. We don't know what these regions are though. 3 away, that's yellow, so this must be pink. This is high, this must be medium. So this is 4, 5, and 6. 2 away, we have 5 and a high digit. This is pink, that's yellow. 3 away, we have pink and yellow there. That's 5, that's a medium, and this must be a high digit. That's low. 1 away, we have medium, high pair. We don't know the regions. 2, we have medium, high pair. We don't know the regions. 3 away, we have yellow, so that must be pink here. And this is a green or a high medium pair because this is low. 5 away, we have 1, 2, 3, 4, 5, which is a 2 and a high digit. We know there are different regions, but we don't know which. 2 away, this is pink and yellow. This is 5 and a high digit with the 2. 4 away is 1, which is low, and it's pink. Therefore, this is yellow and high. 1 away, we don't know the regions. One of them's medium, one of them's high. 3 away, this is high, and this is a different region than this. So this must be medium because this is low. And we have just these 2 paros left. Ugh, that's not really that helpful. Let's remove the green, red, and blue coloring. Because right now that's not too helpful. Okay. Let's just fill in the rest of the digits. So this is 5, 6, 7, 8, 9. This is 1, 6, 7, 8, 9. Okay. Remaining digits in column 4 are 4 through 9. Obviously no 4 here because of 4 in the box. Okay. Remaining digits of column 5, we have 1, 5, 6, 7, 8, 9. Obviously no 1 here. Remaining digits of column 6, we have 1, 4, 5, 6, 7, 8, 9. And no 1 here, no 4s here, because of 4s in the box, and 1 in the row here. Remaining digits in this box 6 are 1 through no 3. So 1 through 4, 5, 6, 7, 8, 9. No 1 or 2 here. We don't really have that much information though. Okay. Okay, this is yellow. Oh. Why can't this be 4? This should be able to be 4. Okay. Yeah. Hmm. 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 Um, hmm. We know this is a pair of green and red. This is a pair of green and red. So these two must be a pair of green and red, right? Green, red here. Green, red here. Because this is low. And this is red, so this must be green. So this is 4 or 6, which means these two must not be the same region. Okay. Because 4 and 6 are definitely consecutive with 5. Um, hmm. Um, hmm. Hmm. Um, if this is 2, then this also has to be a 2. Okay. Does that help us any? I don't really know. If this is 6, this then has to be different regions, so this would be yellow. Does that help? I don't know either. If this is 6, obviously this would have to be a high digit, so that's fine. So really, I guess it's these paros that are the interesting thing. Maybe, oh, I think we've gotten most of what we can from the yin-yang shading. Hmm. How did I know this was 7, 8, or 9? Oh, because of the 2. That's why. Hmm, hmm, hmm. These are different shadings. So if this is yellow, this is pink. If this is pink, this is yellow. That's a problem. If this is yellow, these two would have to be yellow, and then therefore these would have to be pink because these can't be consecutive with each other in the same region. But we know that's a deadly pattern in yin-yang shading because if these are this opposite shading of this opposite pair, how do you orthogonally connect the pink regions without breaking the yellow regions apart? You can't. Same with the yellow regions, right? It would break the pink regions into two separate regions. So this cannot be yellow, which means this is pink, which means this is yellow. This pink means this is a different region than this, so this must be yellow. We have two yellows here. We have three yellows here, which makes that a pink. These are a yellow diagonal. So one of these is yellow and one of these is pink because of the same deadly pattern that we had here. So we have yellow here, yellow here. Same with this yellow diagonal. Hmm. Okay. Can this be pink? If this is pink, that would force this to be yellow, and this to be yellow. If this is yellow, that would force this to be pink and pink. So these are opposite colors, aren't they? If this is yellow, this has to be pink because of the 2x2, and this has to be pink because of the 2x2. If this is pink, this has to be yellow because of the 2x2, and this must be yellow because of the diagonal. So this is opposite what these two colors are. We'll mark that as red and blue then. Right? Because if these are the same, that would be a bad... yeah, these can't be the same because that would force... if these are the same as pink, there would be a 2x2, which is all pink. If this is the same as yellow, this would be a 2x2 that's all yellow. This can't be same set because then you'd have either 2x2 that's all yellow or the deadly pattern of yellow and yellow across pink and pink. In the diagonals. So 2 away could be yellow and pink. That could be possible. 4 away would have to be yellow and pink there. 5 away could be yellow and pink 2 and 5. 4 away would force that to be 3. And that's possible with that being high. 6 away. 7 away would mean that's red, and this would have to be blue. Doesn't tell us very much. Oh, these cannot be consecutive because they are both yellow. So you cannot have 7, 8, or 8, 9 here. So this must be a 7, 9 pair, which eliminates 7 and 9 in the rest of the column and in the rest of the box. So this can't be 7 or 9. It's 8, which eliminates 8 in the rest of the column and rest of the row. Interesting. That was kind of cool. I don't feel like this is hard. I feel like this is very hard to me. This doesn't feel like a very simple puzzle here. Anyways. What else do we have? Most of the paros are done, though. Hmm. Hmm. Um. Hmm. Oh, that's interesting, though. Since this is going to be, these are different regions, this is going to have a diagonal where it's going to be the same region as it, which means it would have to go that way or have to go that way. Ah, so, well, that's interesting. If this were pink, pink, sorry, if this were yellow, yellow, that would mean pink is there. This would have to be yellow, and then this, so this cannot be yellow and yellow. But this could be yellow and pink here, right? Hmm. Hmm. Interesting. Ugh. Okay. Six could work if this is yellow and that's pink. That doesn't work. So if we had six here, this would be yellow, obviously, and this would be pink. But this would be a diagonal of pink, so it would have to go pink here. But then this would be pink, pink, because any yellow here would not orthogonally connect out. So this cannot be 6. That doesn't help us very much, but anyways. I don't think this can be pink in general, right? If this is pink in general, again, that forces this to be pink here because of the diagonal. And then these are all pink, and then this would be a 2x2 area that's all pink. So this can't be pink, this is yellow. Um, hmm. The pink must exit out either this way or this way. Pink could be here. Can this be yellow is kind of the question. So if we have yellow here, that would be diagonal of yellow here. So this would have to be yellow here. Therefore, that would be pink. You have to orthogonally connect out. That's pink. Both of these can't be yellow, so one of them's pink. So we have pink there guaranteed. So far, that looks okay. Obviously, this couldn't be 4 or 6, so it'd be 7, 8, or 9, because they would be the same region. I guess part of it is... We know this is yellow because of that. What happens? So what happens if we make this pink? Then this has to be yellow. That makes this pink. So therefore this is yellow. This has to be pink then, which forces this to be yellow and yellow. That seems fine also. Hmm. Hmm. Okay, what happens if this is yellow? Then this has to be pink here. Um, seems fine. Hmm. I need to pause. I'll be right back because I need to go to the bathroom. I'll be right back. And I'm back. Let's continue. Oh, this is not just hard. This is definitely a very hard puzzle, in my opinion. Um, hmm. If we had 4 here, then this would be pink, which is fine. But this would have to be a high digit, which would be 7 or 9. And therefore that would make no 7-9 pair. This would have to be 2. This could not be 4 or 5, so that would make this 6. That would make this 5, and therefore that would not work, because this 4 and 6 would force this to be 1, which is why that would be 5. And then these would be consecutive, which is not allowed. So, this cannot be 4. That was a pretty long, convoluted way of pointing that out. Anyways. So 1 and 2. So either this is pink or this is pink. Or both of them could be pink. We don't know. Okay. So we tried 4 here. That means this is high. We have high here. No 7, 9 here. This can't be consecutive. So that would be 6. 4 and 6 would eliminate 4 and 6 here. So that would be 1, which means this can't be 1, 7, 9, or 6, which would be 5. And 6 and 5 would be consecutive. So that's that information. This is 1 and 2. It's going to have a medium and a high with it. So either this is medium and high or this is medium and high. We don't know. Can we have 7? Yes, that still could work. So which are the one? Okay, so which are the ones that are completely done? Oops. We'll mark those as green. 6 is completely done. It has 3 and 8, and there are different regions. 1 is kind of done. Red will mark as the ones where we don't have any of the, how do you say it? Wait. The only way this can be 1 is if this is 2. And 2 away then would have to be not 1 there. Right? Because this would be 2 away, have to be different entropy levels, and 1 would be different. So this can never be 1, which means this is a 1-2 pair here. So this is 1-2 as a pair, which eliminates 1 in the rest of the row. That means this must be a 1 here. Interesting. Okay. These are different regions, so that's fine that they're consecutive. Hmm. Anyways, okay, so that's interesting information there. One, we have some information. We don't know which one's high, medium, and which one's high. Five, we have pink and yellow, and we have this is 2 and this is high. So that's essentially done. 2 away has 5 and 7, 9, and they're different regions. 3 away has high and medium, and they're different regions. 5 has, we don't know what the regions, we do have the regions. It's 3 and 7, 9, so that's done too. 3 is 5 and 7, 8, and 9. We have the different regions. 1, we don't have the regions or the higher fives. 2, we don't have the higher mediums. And then higher mediums here, we don't have the regions. So that's not done. 3, we have the regions, but not, so the ones that are problematic are these specific. This we have the regions, but we don't have the high or mediums. This we know one of these is pink, and there is a high and medium, but we don't know which is which. With 4, we have 1 and high, and there are different regions. 5, we have 2 and high, so this is, but we don't know which of the regions are. 2 is done here because we have 5 and a high digit, and they're different regions. 4 is done. 1, we don't have very much information yet. 3, we have, this is medium, that's high. And they're different regions, but we don't know which regions. So, one of these is yellow, one of these is pink. We don't know which. Hmm. Okay. We don't currently have any information about consecutiveness. If this was 4, we had 4, that would be 6, that would be 8. These would have to be different regions. 3 and 4 would have to be different regions. So therefore that would be pink. That would force this to be yellow. Yellow has to orthogonally connect out that way. 4 and 5 have to be different regions, so that would be yellow. This would be different regions, so it's pink. This cannot be 5 then, so this would have to be 5 there. So we'd have yellow, yellow here. That forces yellow to be there, which means that could not be 4. 2 and 2, this would force that to be yellow, which would force this to be pink here. If this were, this can't be yellow, yellow. So one of these is pink. And you cannot have, how would that work? Obviously, if this is yellow, this would have to be pink, which could work. Obviously, this wouldn't be 4, so this would have to be 4 here. Hmm. This would not be 6 here. No 4 here. These digits, oh, well, these digits cannot be consecutive. So there can't be 7, 8, or 8, 9 here. So this must be 7, 9 as a pair, which eliminates 7, 9 in the rest of the column. So far, this is fine. So that would force this to be 8. No 8 here. They can be consecutive, sorry, because this 8 is not consecutive with 7 or 9. So this would have to be 5 in that instance. Okay. This can't be 4 because of consecutiveness, which makes this not 4, not 8. Therefore, this is 4. This can't be 8. It's consecutive with both 7 and 9, and they are the same region. We have 5, 7, 9 here, so that would force this to be 4. And we have a contradiction. We have 4 and 4. Oh, well, anyways, yeah, we never had a 4 there anyways in the first place. Okay, well, that was a lot of work for nothing because we already knew 4 was not here, so this is not 4, this is 7, 9 as a pair. Which means 7, 9 cannot be in the rest of the row, so this can't be 7 or 9. It's 4, and it can't be in the rest of the box, so this is not 7, 9. This is 5, 8 as a pair, which eliminates 5, 8 in the rest of the box and row. So no 8 here. 4 eliminates 4 here, so that's 8. So no 8 here. 4 eliminates 4 from being here. So 4 has to be here. 1 has to be here. This is a 1, 4 pair. And does it tell us anything else? I don't really know. This is 5, 8 as a pair. How did we know that? I don't remember. Oh, because 4 can't be here. 8 can't be here. This has to be 7, 9. Right. We have 4 and 6 here as a pair. 5 and 8 as a pair. These can be consecutive because 5 and 8, sorry, these can be next to each other because they can be in the same region, I should say, because 5 and 8 are not consecutive. 1, 4 as a pair. Okay. This, well, we have that so far. That's not helpful. This is 8, so this cannot be high. So this has to be 6. So this is 6, which means these can't be pink because they would be consecutive. So this is yellow. We have a 2 by 2 that's all yellow, so that's pink. These are different regions, so this must be pink here. Yellow has to orthogonally connect out, so that's yellow. Since these two are yellow, 8 is consecutive with both 7 and 9, so this can't be 8. That's 5, that's 8. 5 is going to be consecutive with 4 or 6 no matter what, so these have to be different regions, which means this is pink. So this is pink, which makes that yellow. Okay, this is 2 by 2, that's all pink, so that's yellow there. This is a diagonal that's yellow, so this has to be yellow here because you can't have a cross diagonals of different colors. This can't be 4 then because it's the same region, so 4 has to be in column 3 there, which means none of these can be 4, none of these can be 4. Wait, what did I just do there? Oh, this is 4, which eliminates 4 here, and these can't be 4. That was already not 4. Because of consecutiveness, 6 can't be consecutive with 7, so this is 9. No 9 or 6 here. It's 5, 7 as a pair, which limits 5, 7 in the rest of the box. This can't be 7 or 9. It's 8. This can't be 5, 7, 9, or 8, so that's 6. That eliminates 6 from the rest of the column. So this has to be 8 with 7 or 9, which means these cannot be the same set. So we have to have one pink and one yellow here. If this were pink, this were yellow, the pink would not orthogonally connect, so this must be yellow here, which makes this pink here. Okay. These are different sets. If this is we have one each of... Do we have one each? We don't necessarily. This cannot be 2 yellow, so we are guaranteed 1 pink here. 9 eliminates 9 in the rest of the row. Okay, so then this 2 is done. Three. We have 3 with 5. So this must not be... this is also pink. So this has to be high. So the 3 is done now also. This is 7, 8, 9. This cannot be 6. So we have a 7, 8, 9 triplet here, which means this is high, so this must be medium here. We don't know the regions, though, still. 3 have those. Okay. Seven and 9 would be consecutive with 8, so this must be yellow. Pink has to go out this way or this way. We're not sure. 8 is consecutive here. Or 8 is... These are the same regions, so 8 must be with 5, can't be with 7. Because those are consecutive. This is 7. 7 and 6 are consecutive. So this must be pink. These are 2 pinks, so therefore that's a diagonal, so this must be... Oh, sorry, cannot be pink. That's yellow. 2 by 2, that's all yellow then. This must be pink. These are different regions, so the pink has to go out orthogonally. So it must go here. This can't be 5 because they are the same region, therefore it cannot be consecutive. These are different regions, so this is yellow. Pink has to get out orthogonally, so that's pink. This cannot be 5 or 8. No 5 here. This is 4, 6 as a pair, which eliminates 4, 6 in the rest of the column. 5 and 8 eliminate 5 and 8 here. This 8 eliminates 8 here. Where? We don't know. So this is pink, which makes this yellow, because these are consecutive. So the 1 is now done. 5. We still don't have very much information there. 3 cannot be consecutive with 4 in the same region, so this is 6, this is 4, this has to be yellow. So therefore, these are diagonal of yellow, so this cannot be pink. So orange has to be yellow, and dark has to be pink. So that satisfies that and the 3. So we just have these 3 pairs left. Okay. So this is a 3 by 3 that's all yellow. Therefore, blue cannot be yellow. Blue has to be pink, which means red has to be yellow. Blue has to orthogonally connect. Pink must orthogonally connect. Pink has to orthogonally connect here. This is diagonal, that's all pink. That connects there then, because this can't be yellow. Diagonal of pink. We know one of these is pink at least. This goes pink here. It has to orthogonally connect, so this is pink. This cannot be 4 because that's consecutive with 3, and they're in the same region. So this is 1 and 4. That eliminates 4 in the rest of the row. 1 eliminates 1 here, so where is the 1? In column 6, it has to be here. 4 eliminates 4 here, so it's 6. That eliminates 6 in the rest of the box. And row. So this cannot be 6 here. This is 7, 8. And this, for this, actually this wasn't completely done. But this is high. This has to be medium then, for this to be entropically correct. So this is 4. This is 7, 8, and 9. So 9 has to be one of these two. So 9 cannot be any of these. We have a 7, 8, 9 triplet in box 8, which eliminates 7, 8, 9 in the rest of the box. This can't be 7, 8, 9, it's 5. This can't be 5, 7, 8, 9, it's 6. Okay, that eliminates 6 from the rest of the row. We have a 7, 8, 9 triplet in row 9, which eliminates 7, 8, and 9 in the rest of the row. So now it's 2 or 5. Well, 2 away would be 1, and they would be the same entropic set, so that doesn't work. So this is 5, that's 2, which makes this 1 and 2. 5 eliminates 5 in the rest of the box and column. This can't be 5, it's 6. No 6 here. This is 7, 8 as a pair, which eliminates 7, 8 in the rest of the row. So this can't be 7 or 8, it's 5. That eliminates 5 here. This can't be 4, that's consecutive with 5. This can't be 6, that's consecutive with 5. So we have a 7, 9, 7, 9 pair. And we have 1 away here, so this must be pink, and it has to be medium. So no 6 here, no 5 here. This is 4. 4 eliminates 4 here, so it's 7, 9 as a pair. 7 eliminates 7 here, so it's 9, which makes this 7, which makes that 9. This can't be 7 or 9, it's 6. This can't be 1 or 6, it's 4, which makes this 6, which makes that 1. 8 eliminates 8 here. Eliminates 8 here. 6 eliminates 6 here, so this is 4. And this can't be 4 or 6, it's 7, 8, or 9. No 9 here. These are consecutive as 7, 8. Therefore, this cannot be pink. This has to be yellow. And this is pink. Pink has to orthogonally connect out. So that satisfies that 1. 4 and 5 are consecutive, so they cannot be in the same region. So that's yellow. Pink has to orthogonally connect out. This is a diagonal of pink, so this must be pink here. 9 makes this 7, which makes this 8. 7 eliminates 7 here, so it's 9. No 9 here. 5, 7, and 8. 9 eliminates 9 here, so it's 7 and 9. 5 eliminates 5 here, so it's 7, 8 as a pair. 7, 8 as a pair eliminates 7, 8 here, so that's 9. No 9 here. 7, 8 as a pair eliminates 7, 8 in the rest of the row, so that's 9, 7, and 8. This can't be 7 or 8, it's 9. 7 eliminates 7 here, so it's 5. This is a 2 by 2 that's all yellow, so this can't be yellow. That's pink. I think it has to orthogonally connect out too, right? Yeah, because this is not orthogonally connected to the rest of the pinks, so it must connect there. 2 by 2, that's 3 pinks, so therefore this is yellow. Yellow has to orthogonally connect out. It's there. 2 by 2, that's all pink, so this is yellow. Okay, let's make sure that all the paros work. 6 goes with 8 and 3, and they're different regions. 1 goes with 5 and 7. That's different entropies, and they're different regions. 5 goes with 2 and 9, and they're different entropies. 5 goes with 9 and 3, and they're different entropies. 3 goes with 9 and 6. Those are different entropies. 2 goes with 5 and 7, and those are different entropies. Sorry, I don't know why I'm saying entropy. Different regions. 3 goes with 5 and 9. Those are different entropies and different regions, I should say. Maybe I was just like, yeah. That works anyways. 1, 4, 9 different entropies in pink and yellow. 1, 4 with 7 and 8. And that's pink and yellow. So different entropies. 1, 4, 7, and 8. 8 forces this to be 7, which makes that 8. Makes that 7, 8, and 7. So this would be 8. Let's just double check. 1, 4, and 7 different entropies, and they're yellow, pink. 2, 8, and 6 are different entropies, and yellow, pink. 3, 5, 7, or 8, or 8 actually, different entropies, and yellow and pink. 1, 4, 9 different entropies, yellow, pink, yellow. 5, 2, and 7 different entropies, and yellow, pink. 2, 5, 7 different entropies with pink and yellow. 4, 1, 7 with pink and yellow, different entropies. 1, 4, 8 different entropies, pink, yellow. 3, 6, 7 different entropies, and yellow, pink. So do we want to go through? This is not 9, that's 7, that's 9. Do we want to go through and make sure they're not consecutive too? Ugh, okay. 4 is not consecutive with 8, not consecutive with 3. No, 5, 9, 7, 1, 6, 2, 4, 7. 1 is not consecutive with 7, 8, or 3. 3, 1, 3, 6, 6, 2, 2, 5, 5, 9, 9, 1, 1, 3, 3, 8, 8, 2, 2, 4. Let's go this direction. 4 is not consecutive with 1. 1 is not consecutive with 5 or 7, which is not 7 is not consecutive with 4, which is not consecutive with 1. 5 is not consecutive with 9, which is not consecutive with 3, which is not consecutive with 6. 4 and 7 are consecutive. 7 and 1 are consecutive. 1, 4 is not consecutive. Neither is 4, 7. 1, 8, 8, 6, 6, 4, 4, 2, 2, 7, and 7, 2. So the pinks are not consecutive. Yellow, 9 is not consecutive with 2, which is 6, 9, 9, 7, 7, 5, 5, 8. 8, 4 are not consecutive. 4, 2 are not consecutive. 8, 5 is not consecutive. 5, 9 is not consecutive. 9, 3 is not consecutive. 9, 5 obviously isn't consecutive again. 5, 8, 8, 2, 2, 4, 4, 6, 6, 8, 8, and 3 are not consecutive. 2, 6, 6, 1, 1, 9, 9, 7, 7, 1, 1, 9, 9, 5, 5, 3, 3, 8 are not consecutive. 3, 6, 6, 2, 2, 5, 5, 9, 9, 1, 1, 5, 1, 6, 6, 3, 3, 7, and 7, 4, and 4, 8. And therefore this is at 8. Yeah, this is not hard. This is very hard. I don't know why people are saying that this is just hard, because there's a lot. This execution is definitely very hard. Even the logic is not necessarily easy either. So execution-wise, this is definitely the highest difficulty. Logic-wise, it's still really hard, and I don't even know if that we have necessarily. It might still be very hard logic too, but it's really hard to judge the difference of logic necessarily. Yeah, I would place that as very hard. And either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.